not able to even go ahead a little bit because there were no diagrams. And of course, I can understand that was very difficult for you people to understand what I was speaking. So anyway, so this is a new topic that is, I mean, you did high rise last year, but it was mostly related with core and the structure and how do you go such high levels. But I do not think you guys touched on the services level. And when you're talking about services in a high rise building, well, they are all together at a different level because you are talking about much more complexity, simple things like vertical transportation. I cannot even think about having the normal speed like what we have in a normal G+7 or 8 building, where the speed of the lift is 1.2 meter per second. When I'm talking about high rise, and the lift speeds will have to be increased, and the speed will have to be increased with the fact in mind that people shouldn't be feeling uncomfortable inside. So all these complex.
We can't hear you. Can the others hear me now? No.
No.
Meenal, are you around? I
No.
think it got hanged for a
I'm
minute.
on mute. I'm on mute.
Oh,
Oh God!
okay.
So I spoke this time, and none of you heard anything. Okay, so
No,
guys,
in between it got cut. So,
I तो अपने आप कैसे mute हो जाता है रे? Anyways,
Good.
so so these complexities will be there, like lifts, fire, the drainage, everything will have its own problematic issues, and we'll need to look at it in a different manner when we are talking about building going 60 floors, 70 floors, and in case of Burj Khalifa, some 160 floors. Like that's dynamic. How do you even think about a mile high up in the air? And now the few buildings are planned, I think 2025 or maybe even before that. Saudi Arabia is having probably even taller than Burj Khalifa. So the sky is the limit. But in such a scenario, guys, there are issues with the services. And since we all know that services are a daily requirement for the comfort and the safety of the people, well, without saying anything, you know that it has to be proper and it has to be done with a very, very comfort and safety factor in mind. So this is what entails when we talk about high rise and any architectural project for that matter. You would have a design team, you will have clients, and you will have builders or the contractors. So these are the stakeholders. Okay, now why am I showing you this here? Because when you see the design team, the number and the complexity of the design team as well as the builder will increase far more. Client will probably just one, or probably even the clients will be more, because you never know when you're talking about Burj Khalifa, there are different kinds of clients which is inside. So the stakeholder levels are pretty high in a high rise building, and especially in the builder level when I'm talking about MEP, oh sorry, design team, MEP consultants, structural consultants, services consult, all kinds of various kind of consultants will come in. The coordination that has to happen between all these, it's a big huge task. Okay, and lot of coordination is required, especially at the level of uh, at the level of construction, or maybe even at the planning level. Okay, oh sorry, once again. Yeah, so these are the interactions. Okay, so this was what I was trying to tell you last time, but unfortunately you couldn't see the thing, but you see the kinds of interrelationship between the services. So you start with the architecture because that's what we are, and we always think about the form and how we want the building to be. Because as I said, buildings, when we go tall, and if you don't plan out well, they are very mundane. They can be a sore thumb because what do you see? One above the other stacks of the stories, and that's it. But with the new kind of fad that is coming up, or the fashion or the trend that is coming up in the market, is having an iconic kind of a feature for the high rise, and how can one achieve that? So architecture is obviously deals with the form, deals with the program, and deals with the envelope. uh, and all three has a very strong say in the form of architecture. Okay, now if I just take the form, okay, I will not go in, or maybe I can even explain the whole diagram. You just take a look at the form. When I'm talking about how the entire building is standing, obviously I'm thinking of core. of what are the structural core members that is being used, or even the material that is being used. Is it steel completely, or is it a composite, or is it completely concretized? Okay, what kind of structural frames have been used? And I'm sure you have done this in the fourth year, and I repeated some of it last time, so I'm not going to go into that at all. Okay, so form is related with the core definitely is related with the elevators, because, and here elevators are the prime importance, as I said, because otherwise it's impossible to travel within a building, and then there is pointless to have such a high building when you can't reach from one place to the other in a minimum amount of time that is required to be there. So elevators then become of a very, very prime, I would say, importance. Okay. Also, core relates with the structure, and then when I come to structure, it relates with the framework and the foundation as well. So this kind of interrelationship is seen throughout. Then structure is also related with the mechanical, and then A is equal to B is equal to C. So architecture is related to mechanical. Okay, and we all know that. So when I talk about mechanical, look at the arrows. That I think the maximum number of arrows that come out is from the mechanical. So you have plumbing, you have electrical, okay, you have HVAC system, and in the electrical you have municipal infrastructure. Plumbing also, of course, municipality provides you with potable water. It takes away the sewage. It gives you the electricity. Okay, so these kind of complexity one will have to be aware of when you are dealing with it. Then you have in the plumbing, then you have the firefighting, so fire protection will come in. Electrical is also related with the fire protection, because your detection system, okay, your alarm system, your announcement system is all dependent on electrical. So plumbing as well as electrical is completely associated with your all kind of safety procedures. Then on the other hand, when I'm talking about envelope, the envelope is related with the mechanical, because this is where I am controlling my sun coming in, my wind coming in, how am I protecting my building, and especially when you go up high and you have glass facades out there, you have to take care that it is support, it can take the lateral loads, or the chances of being, it moves, it kind of creates sound. All that has to be thought of when you're talking about envelope. So the detailing, the kind of thoughts, the material has to be very clear in architect's mind. Communication controls, okay, obviously related with electrical, because EPBX system needs to be installed within a building. Okay, IBM systems are there, building management system that we had a lecture last time, where complete control of the building is at one point. Okay, or even if it is a multi-point, multiple point, at least one point is even associated with those multiple points. So essentially, what happens is it's like the nerve center. Okay, so it knows the ticking of the building, what goes wrong, what changes, which systems are done. So that is a kind of a nerve center that these kind of buildings will require, and it's not ki sochenge. It is mandatory that they have these kind of systems available. Otherwise, it will be impossible to depend the entire Burj Khalifa to depend only on a human control of the system there. Impossible. So these are the and there are many interrelations that I have not yet talked about. Okay, but you need to think about safeties and vertical transportation, and what kind of systems then that can come about. Okay, so this was about the interrelationship of the. Why am I take control? Somebody's taking control. Okay, okay. So how do you define high rise? Quickly, I explained to you last time. As per the bylaws, I'm not going here again, okay? Because this was definitely didn't require any this thing. But just by the thing, basic firefighting, जहाँ पे नहीं पहुंच सकता है, I would require firefighting. My footprint ratio is highly skewed. Okay, I am meaning a slenderness ratio. I'm thinking about slenderness ratio. When the tallness of the building strongly influences its design and planning, as I just repeated, right? Or as I just said, that when the tallness I'm talking about, that means lifts becomes too important. When it is very high building, then my envelope becomes very important. When it's a very high building, my HVAC system becomes very important. My drainage becomes very important. How am I going to take care of the gravity and which the thrust which the drainage will be flowing down? I need to take care of all of that. So yes, all my design planning principles will change when I'm talking about high rise building, and that is exactly then you can say that yes, this building is high rise, because you have to think about each and every services, not in the normal way, but you will have to give it a little specialized treatment. Okay. I'm just skipping all this, okay? So these are some of the stability and the structure that I already finished last time. I'll swiftly go to, these are the systems that you will have to do: water supply, drainage, alternative source of water, fire safety. And we have been talking about alternative source of water. Kimaya took a lecture on the waste management, waste water management completely, right? So all kind of systems that is possible. So even in these buildings, especially in these buildings, because the need for the water is in like million MLD kind of thing. Okay, definitely rainwater harvesting will help. Recycling of water will help. So at least the demand of the water will be reduced. Okay, so it's imagine such kind of buildings popping up everywhere. They are like point loads now on the infrastructure. Like a building has a point load, where certainly at one point a lot of load is coming. Similarly, a city, suddenly you have a normal city, and then you have a vertical city. So city within city is going to kind of, it's a point load for infrastructural systems for city. So all these things, we are not going to really go into everything, but just remember, I'm not going into the internet connectivity and telecommunication, because all that is done with the computerization and done with the IBM, which we have already finished. Okay, so I'll be taking water supply. What are the things that one has to be very careful about? The drainage, which is a very small part, but it needs to be taken care of. Fire, of course. Okay, waste management is a big issue when you are talking about 70 floors, 80 floors. You can't expect a person manually to go up 70 floor and carry down so much of load. I mean, he will probably take 3 days to collect the load. So there has to be a system in place where the garbage chutes and everything is designed, how they are managed, what happens if the things get stuck. So is IBM applied there? So we'll study all those systems. Okay, security systems, again, we have finished all that. Acoustics, no way, we are not even touching that here. Okay, so these are some of the systems that I will try to cover up with you guys. So coming with the water supply, which we have already done in the second year, third year, okay, and partly in fourth year as well. But the difference here is that you really have to think about the load the building is going to carry for the storage of OHT, the sizes of the UGT and the OHT, how they are going to be managed, what kind of water systems will be there. Are you giving it pressurized system, meaning pneumatic systems, or you are having gravity? If it is gravity, then you will have to take care of the pressure. So these are the stuff that you will need to think as an architect and accordingly suggest the system. And of course, you will have a plumbing consultant who will then tell you that if you do this, these are the consequences, and if you do that, that will be the consequence. So then based on those inputs, you will have to come up with a system. But ultimately, you are the one who is going to design the system, in the sense, the placement of the UGT and OHT. That is completely in your hand. Okay. So in the previous slide, it was just basically the recap of the water systems that we have been doing. So that was a small thing where you have no UGT, no OHT. Okay. In the second one, you see that there is a UGT. Okay, but there is no OHT. That means only the pump is utilizing it. So you have only intermittent. जब तक pump है, तब तक पानी है. When the pump shuts off, you don't have the water. So this was a very initial kind of thing. Then you have the normal one, which I have already talked to you about in the second year. Okay, then we go for the. A lot of time people come up with the question. So is that if there are two high rises, and or there are two buildings, or there are two structures, and they both are separate, so do I need two OHT, or do I need two UGT and two OHT? So this is a diagram which kind of tells you that you can have one pipe going up and supplying two separate OHT. Possible. Okay, and multiple floors can be there. The piping can be done. So what I'm going to do today is, after I finish the lecture, I will upload a small video on your files. Please go and have a look. It's a video on Burj Khalifa and the water supply distribution for that. It's a very animated, nice kind of thing, with the engineers trying to explain. It's 4 minutes. So please go and have a look at that. Okay. The next slide is about pneumatic systems, where you zone the buildings. Okay, so you zone the building. So we, even in PRV, we zone. The PRV is pressure reducing walls, where you will say, okay, my first pipe is supplying the first 10 floors, the second pipe is supplying the second 10 floors, and the third 10 floors, and so forth, so on. So and at every point, you will be having a PRV. So that is how the PRV systems work. That is pressure reducing wall systems. It reduces the pressure so that coming from the top, by the time it reaches the last 10 floors, the pressure is going to be tremendous. You know, the pressure increases with the depth, especially of the water. So as the depth increases, you are going to have problems when you are reaching the ground floor. So how do you take care of that? So one system is PRV. The other systems is you use pneumatic and you zone it. Okay, but pneumatic we know is very costly affair. It's very non-green affair. Okay, it takes up too much of energy unless you are having solar, and for that you will need a huge solar panel. So that's not done. Okay, so this is I kind of like this program because when we talk about high rise, and again I'll give you the example of the Burj Khalifa because that is very popular building and it is one of the highest building. You see that there are numerous floors having other functions. Okay, so somewhere there are restaurants, and it's not just one restaurant. Okay, there are plenty of restaurants. So every restaurant is going to pay its own bill. Now, who manages all that? So there are systems of revenue also, which I will not go into this. But coming to the infrastructure point of view, if a person is to charge them, and they know that this is a high flying kind of a very kind of a fine dine restaurant where they can afford to pay that, so obviously they are going to have a separate metering system. So this is how it is done. So you see the water meters. Okay, at every level you could have that, or you can have the water meters down and function it like this. But then when you are zoning the water meter will have to be at that zone level. It can't be at the ground level. Okay, UGT to ek upar fenkta hai. But from there, when it is zoning out, again every line and it will be supplying a certain thing, you will have to have its own water meter. So yes, you will have to have this kind of even the revenue systems has to be thought of when you are talking about high rise, multiple complexes or complex systems that is happening within a high rise. So separate meters are provided at separate floors, probably for separate establishment within a floor. So even if the floor is of a very large area, and you might have two probably theme restaurants happening there of a large kind, maybe G+1. So yeah, in that case, you will have to have two water meters staying there at that particular floor. So these are the systems that you will have, which you will never even think about in a normal G+7 building, because or a G+10 building, or for that matter G+20 building, because generally in a G+20 building you would have first three floors or first two floors as a complete complex commercial thing, and everything is managed at the lower level. Not so in a building like Shanghai Tower or Everest sorry Hearst Tower or many other towers that we have been hearing about. So this is that multiple pressure, multiple tank system, okay, where you are having a tank, you zone it out, okay. So generally, you, as I told last time, there is something called as the mechanical floors, which are not same as the service floor. Service floor essentially works so that it differentiates the services. So if you have a residential floors on the top, and then below you have, say, some public floors or the public sector, in the sense you have banquets there, you have restaurants, or you have lounges there, or you have some offices there, whatever. So obviously in a house you will have proper toilets, you will have kitchens, and you have all the pipes coming down. Now if they are not placed externally, and most of the time in most of the countries, especially in the cold countries, they try to house all the services inside because it's too cold outside and water freezes, so they try to protect the water. That's the reason why the toilets are inside, unlike in India. So India, probably high rises, we will have everything happening outside, we might not face a problem. But if it is internal, i need to I need to take control of the pipes not coming into my commercial area, so that I can have one nice big long open area, and no ducts within. Okay. So if that is my planning idea, then I will have to introduce a service floor. Now, mechanical floors are a special entity only for the high-rise building, because in a high-rise building, as I said, imagine in that 4 minutes video that I'm going to put up, the engineer says that it will be impossible to imagine a single water pipe, even if it is 6 inches or 8 inches, to take the load of the water, or imagine the size of the pumps for that matter, which has to throw the water 160 floor up, 160 multiplied by 3 meters. Okay, and several of the floors are double heights. So and then you have 160, so the height is like tremendous. the pipes will burst. According to their engineering science, they say that if I allow the one pump or multiple pumps to put the pressure up and allow that water to rise to 160 floors, the pipes will burst. So what they have done is they are doing it that from the ground floor or from the basement, wherever the UG is, from there it goes to the first tank. Okay. Now from the first tank, there will be another set of pump there. From there, it is pumping it to the second. From there, it goes to the third. So every floor, wherever there is a UG, there will be a set of pumps there. That is how the water is taken up, because otherwise, and you will see that when he explains to that in the Burj Khalifa, you will understand that how he's saying. He has used a term there. The water pipes and the water pipe systems in Burj Khalifa is like a spaghetti bowl. Okay, so many pipes are emerging from one place, you don't know what is beginning from where and ending where. And so he is very specific about how the things are to be done. Okay, and you will see some of the examples of how big the mechanical flaws are. Similarly, the same thing will happen for your fire tanks. Cannot have fire tanks only at the OHT level. That will also have to be segregated. Same thing will happen for your HVAC system. Cannot imagine I will have one HVAC system for a very complex system like Burj Khalifa at the basement and expect that chill water to go all the way up. That would be madness. Okay, if a simple water will not go, imagine chill water going up. It will just not function. So you will have this separation of zoning. Okay, or the zoning and then the services separately. So yes, there will be multiple installations here. So we talk about na ki installation costs are costly, and so we try about adjusting a system which will take care of the entire building. Not so in a high-rise building. Yahan pe you will have to go for multiple installation, and you'll have to zone out the building. So this was, well, I don't need to explain here. You have done it, but I'll show you the other diagram which you have done in your second year. This is the diagram that shows all PRV, your multiple tank system, your brake pressure tank system, and finally your pneumatic system. So pneumatic system is the last one where it sees the, so you see the orange one, that is one, the red one is the other, the yellow one is the third. Then we have, this is from the right hand side, okay? Then we have the brake pressure tank. Then we have the multiple tank. And the final is the PRV, okay? So this is how, and we have done this system in the second year, so I'm not elaborating too much on this, okay? But just imagine the calculations that will forego into this, that will have to be planned. So my intention and my hope is that whenever you take your own projects, or even when you take your AD projects or your IDS project or your thesis project, guys, if you sort out your services, if you do these calculations and keep it there as a backlog, bhulo mat use. You keep it there. Yes, I have to deal with this. Whenever the time comes, just take here and insert it there. Yes, this calculation is done, because it's your AD project. You have imagined something for your AD. If not, someday in future you will imagine that, yeah, I'm going to build this, and these are the number of people I'm expecting, and so I will have to have so and so services whether I like it or not, because you might not like it, but people will definitely not like it if you don't provide the services. So you will have to provide that, and it is, as we have stressed this point, it's a very important part of your black book, because a section of it will be considered as a technology part, and that will be marked separately. Okay, so you will anyway have to prepare that. So keep these systems in mind when, if you are doing housing or whatever you are doing, then all these things will have to go. So this was about the water systems. Okay, so okay, I'll quickly skip this. Yeah, so this is how it happens. So see, in the second diagram, they've used a separate kind of, so what they are doing is, since I assume this is not to be a very high building, but what they've done is they've taken three set of pumps. Okay, ek chota bada, it's like a Goldilocks story. So the nearest pump, nearest tank will have a chotu pump, the usse upar wala will have a middle one, and the top one will have the highest one. But this doesn't function in Burj Khalifa, because imagine the distance as it increases, the more pressure pump will have to apply. So that is where the systems can vary. Okay, but this is also applicable in cases of 20 floor or 25 floors. Okay, so idea here is it will have to be worked on the calculation which an engineer will provide you, because ultimately it ends up paying bills. how much a pump is going to draw in energy and how much the client is going to pay the bill at the end of the day. So that's the entire crux of the problem, and based on which your entire systems are planned. Okay, so this is how my, so see this, okay, every pipe, now that is a pipe either coming from the domestic line or it is coming from the flushing line. So both the lines are here, and every line has that orange stopcock, every line, whether it's on the left hand side or the right hand side. Okay, you see how it is entering. Okay, do you see that concrete slabs in between? Well, that slab protects the hole that will be created when it is done. Now you see the second one, that's badly done detail, because when the pipe is entering the slab, suppose if there is a water hammering, the slab is going to be misplaced, and this should never happen. Okay, and if it happens, it should happen in what is happening in the left hand side. So you cover it with a concrete slab kind of a thing. Okay, or it's not even a concrete thing, it can be just a brick built up. Okay, so you do a hole in a slab and put it inside. The worst scenario that you have to do, suppose you do that, but then you cover that, so in case of any leakages, the things will not leak. Okay, otherwise imagine this in the rainy season, the whole thing will start pouring down like a fountain. Okay, and other thing is, and that I'll show you in the drainage as well, is to hold the pipes in place. The second, the figure on the right is showing you that. How do you hold the pipes in one place? Otherwise, they tend to move. You know, they are very thin, and at that level, people can move them and can create an issue. So that's the reason why. And if you do this, probably they say that the hammering will not happen because it's been sturdy at that area. So this was water system. This is hot water. Again, guys, yahan pe bhi you will be, there will be zoning done, and it is clearly shown. So you see the boilers and everything are there, but calorifiers are placed at the separate zones. Now, calorifier is nothing but the heat exchanger. So it basically like a tube through which the hot water is passing continuously in a loop, goes back to the boiler, come back to the calorifier, go back to the boiler. So that happens, around which you will have a normal water where the transfer of energy will happen, and your normal water will turn into hot water and you get the supply of hot water. Now, if this was a G plus 30 building, 40 building, or maybe even chalo 50 tak, I can have this system. But when I'm talking about Burj Khalifa, it doesn't happen that way. When I go above 70, 80 floors, I will have to now have a two set of boilers. I will have multiple set of calorifiers, where one boiler is probably serving 2 to 3 and the other guy is serving another 2 to 3. So that's how my zoning will take place. Okay, now how much zoning happens will all depend on the kind of usage that building is having. What kind, if it's, what if it is a hospital, or what if it is a five-star hotel, or what if it is plain office? Obviously office wala is going to need so such a little hot water, whereas a hospital and a hotel is going to require massive amount of hot water. So it is not right for me to even comment on it. Okay, that these are the kinds of calculation that has to be done. It all depends on the context of the building and the program of the building. But based on that, you will need to give a space, and that's how much space will be given. Of course, you as an architect knows the thumb rule, but you will be supported with your plumbing consultant guy and the engineer who will be giving you the exact figures, that these are the number of liters that would be required. He will also probably give you a system where you can save the number of liters, that if you can have a little smaller size, because you are ultimately thinking of the score and the structure and the load that is your building is going to take care of, right? So that is also a concern. So he will say that, okay, that's where the break pressure that I keep talking about. So that's the idea. When I really don't want to load my building with so many water tanks, I will go for such kind of systems. Guys, I'm not going fast, right? Because this is all done. So I'm just recapping everything with the emphasis on what happens when there is a high rise. Okay. If you think I'm going slow, please write in a chat box or raise your hands. Hmm? Um, so this is how my hot water system is taken care of. So generally, just remember, any conditioned water, when it has to be taken up, or even for that matter, a plain water, pumps will work only till a certain level. After that, you will need to segregate the system, and that's where the zoning happens. Okay. So this is how it is done, and that is the reason why mechanical floors are introduced, and they become a separate entity which you will never come across in any building. So till fourth year, you did not even know what was a mechanical floor, because high-rise services were never taken with you. But in a high-rise, you will have something called as mechanical floors, okay, and it will house all of this. It will have hot water boilers there. It will have HVAC systems. It will have mechanical ventilation in case if something requires there. Okay, water tanks will be there. Your static tanks will be there. Everything. Yeah, so it's a big place, and it's free of FSI because it houses services. So these are the examples, some of the way and this is what I wanted to tell you, that what happens in a high-rise building. So हम PRV की बात करते हैं, right? Pressure reducing wall. So this is a fantastic solution a Hong Kong building has come up with. So you might have heard about Arup. Arup is a consultation firm mainly dealing with MEP services, okay, along with the structures and other kind of services as well. And I think Arup is pretty famous. If you go on their site, they have fantastic magazines and these are obviously from the magazines that I have subscribed to them. So this is a project in Hong Kong where what they have done is, so imagine you have the water coming from 160 floor of Burj Khalifa, and then you have to use PRV so many times to reduce the pressure. Now, what if I utilize that pressure and create it into electricity? That is exactly what Arup has done for some of the buildings in Hong Kong. I think 2 to 3 buildings in Hong Kong are now utilizing this, and it's catching up fire. That yes, if I can run my lift shaft only on the electricity created by absence of PRV and by taking the pressure out of the water, how can it be done? So amazing way of doing it. I'll show you how. So this was intelligent energy saving. Hydro generation, we all know, is a clean green energy. Okay, and when this is combined in a normal water supply system, what can happen? So the 2 buildings that they have said is in the demonstration in Olympian City 2, where a 100-watt turbine is used, and the electricity generated by this system can power the lighting in a lift lobby, saving some 876 kilowatt per hour per year for only 5-meter waterhead consumption. Okay, so imagine for just 5-meter waterhead, meaning the height. Okay, you have this kind of water generation. You have like so much of water height going up. Tremendous water can be generated. Electricity can be generated by this methods. Okay, so what they do is the hydropower generation system combines an external hydroelectric generator. So instead of putting a PRV, you insert that generator there. Now, when you insert something in the water, obviously the speed reduces, and that is exactly what I want. The pressure reducing valve, it does that. So similarly, when I introduce the turbine, okay, when the water is gushing down because of the gravity, it encounters this turbine does the movement, and there is a generator fitted outside. It's a small generator. Imagine your pipe is having a diameter of 2 inches, or probably, I don't know what will be the sizes in the high rise, probably 3 inches, 4 inches, whatever. And from there, you have a small generator fitted to that. Okay, so that, imagine that. The micro hydro, so that's the use, micro hydro turbine, the first in the world to work in a high rise context, has been installed at the residential building Olympian City 2 and the Lee Tang Avenue in the Hong Kong. So, and Hong Kong has 2, 3 such this thing. Now, this, if you convert it into the green quotient, okay, this represent the saving of electricity I'm talking about. It represents 600 kg CO2 annual emission saving. Imagine, okay, which is equivalent to planting 30 trees to offset the emission. So imagine you are taking away so much CO2 from the earth, okay, or from being generated every year, year after year after year. And imagine, so every year 30 trees are being planted virtually. Okay, so that is the idea about it, and this is a future that is imagined for the high rise. This is how it looks. So you have a water pipe. Okay, imagine this to be obviously vertical. Okay, so this is how it is. Okay, and the turbine goes inside. So when the flow of water is encountered by this gadget, the pressure is reduced. So I first of all get a normalized pressure water, but at the same time, that gushing water is rotating the turbine all the time and creating electricity. So this is how my internal systems could be optimized to get me a kind of amazing solutions for high rise. Another project in Australia, PHES stands for Pumped Hydroelectricity Facility, okay, or services. This is in Australia. If you see the map below, this is on a gulf. I forgot the name. I can't see that. So it's in Australia. So they say that the argument against hydro is that it dams the river. Generally, hydroelectricity is created at the seas are known for tidal energy and rivers are known for hydroelectricity. Now, hydroelectricity में क्या होता है? Basically, you have to pump water from the high level to low level, okay, where the turbines are placed, and with the great flow of the water, okay, the turbines are moved and you create generators. I mean, generator generates the electricity. That is the basic funda of hydroelectricity. Now, so what they do on a river at a high level, they build a dam, okay, and they stock the river water that is happening, which is kind of destroying the environment, ecology, okay, the robust life that exists within the plantation, everything, and flooding happens. So kind of destroying of the ecology, and not considered a good viable solution. But still, people say that counter argument is at least electricity to free or acha milta hai. So, but that's not at the cost of the environment, right? So this project, imagine that if only kind of electricity that I am inputting is to carry the water from the sea, and I dam that water. So if you see the top diagram where that gray pond is there, and you see that white patch which looks very like a dam. So all they do is this. There's niche wala picture mein where they show the pink pipe. Okay, it is taking that water which is only 3 kilometers away from the sea. Okay, they're taking this water, going to that facility, pumping that water up. Okay, and I think because of the kind of generation that happens, they are using kind of and since this is an open facility, Australia is known for having huge solar farms there. So even the pumps are being used by solar. So that cost is also counted. So the whole system is then creating some major electricity for the entire region. So this is one way of how the water systems are done. Of course, this was not related with high rise, but I just love the project and I thought of showing you that these are the ways people are thinking today in going green, okay, and providing it for them. For the other people, this is how it works. Okay, this is how the hydroelectricity works. You have a reservoir on the top from where the water is gushed down. It goes on the turbine. Turbine starts moving, and you generate electricity. And then the water is released back to the sea. So all they need to do is they just need to pump the water up. That is the only energy they are expending. So that is how this project is working. Coming to the drainage. So we finished with the water. If you have any questions, you can write it down or you can ask me later or you can raise your hands. Okay. But we have done this system, so I don't think that should be any issue. But drainage is a little different, okay? Because in drainage, what we learned was it's a gravity, it's a self velocity system, no machines, no pumps, which works even in high rise. High rise also has no pumps. Everything comes gushing down on its own, okay? Everything is still working on self velocity. Now, the problem arises here is 160 floor and the drainage is gushing down. What happens when the horizontal stack comes into contact with the vertical stack? That's where the problem occurs. And this happens like 160 floors, okay? And the kind of usage that you have heard about Burj Khalifa is they have a mall inside and they have hotels inside and they have five-star hotels installed inside. So the kind of services that is being provided is five-star. And when you say 5-star, there is no look back on the services. It could be, it means that the services has to be of 5-star level. Okay. And so obviously there will be no such things like, okay, people are very sensitive and they will not do this and that. Aisa kuch bhi nahi hai. So you can expect the worst thing coming out of that. How do they do that? Okay, let's see it. Now, drainage is comparatively easy managed since it works without mechanical intervention. The main issue is the velocity developed in the stack due to gravity. Okay, various systems are adopted where services, mechanical floors are introduced that we have already talked. at a planned intervention, and velocity is broken at these points. Okay, and I'll show you pictures of how this is done. So there are multiple ways this is done. One system is that at every mechanical floor, so in one of the building case study that I had heard, what they do is they have a mini, and if you see, I forgot the name of the guy. वो कौन है हांगकांग का architect? Ken Young. Okay. Now
Malaysia, Malaysia.
Malaysia, right? So he completely believes his building to be green. Okay, and he believes green to be green in both way. Actual, he uses the entire building as a urban farming, as well as the buildings are green. Okay, so in the sense of electricity. So in some of the if meaning not as high as Burj Khalifa, but say 70, 60 floors, some of the buildings have taken care of the drainage at that level where they are separating it out. Okay, so the mechanical level or the service floors introduced there will be having this primary collection thing, and only the water is allowed to go out. Okay, so that happens at that level. So one part of the thing is done, and the way the building is designed is then takes care of the, so biocomposting happens, electricity could be generated at that particular level. It's very not very possible, but in few of the buildings that has been done. Okay, not a very good solution because anything can go wrong, building can face real problems. Okay, but since it was there, I have mentioned it. So that's one system. The other is you have devices like this. Now do you see this? So you have the drainage coming from the top. Okay, and it gets diverted. Okay, so the central pipe is the one which is having the drainage, and the side wala jo open hai, those are the nothing but the cowl. Okay, where it allows the mechanical sorry the air, in case of any trapped air, to get released. So this is how I divert the flow of the drainage to reduce its huge flow one directionally. So it gets diverted and kind of loses its flow. So this is again known as a velocity breaker, which is applied at every junction where horizontal and horizontal wala alag hai, where at every interval this is done. So I think every 10th floor or every 15th floor this device is used, where they break the velocity. So this is one system. Okay, what happens when the vertical and the horizontal meet? So use these kind of devices. So first diagram shows what happens. Problematic. So the thing is gushing from the top, and then the side one is also attaching to that, and the junction can become a big problem. Okay, so even if I provide a cleaning eye there, who is going to climb 150 floors to clean that? Okay, dangerous, not feasible, and little idiotic. So that is absolutely no, it's not a design parameter. So this is the device that has been thought of, where the top flow is diverted, the vertical is the horizontal flow is going, and then both of them meet at a point and they go down smoothly. So this device happens that wherever there is a vertical stack and a horizontal stack joining at the building level. So obviously if you have 160 floors and you have 160 connections, this will be 160 devices, such devices would be used. Okay, and the last picture kind of shows you that this is how it is actually done, where it is taken through the floor of the duct. And if you see, the duct is covered up with the complete concretization. They have not left anything open. That is because they don't want the fire smokes to go up. So this is called compartmentalization, which we have also done in third year. Okay, but this is an example. So this is exactly how it happens when you don't want the smoke to go up or the fire to go up. This is what is happening at the service floor in many of the buildings. So remember, many of you had questions about what happens at the service floor. So service floor is a place where the drainage is coming from the top, or any other kind of duct is coming from the top, and I do not wish that duct to go down. Okay, I wish to cut it there. So I need to introduce a service floor there. But then imagine you are talking about a hotel lobby, a five-star hotel lobby where all the toilets are centralized, and you will have central ducts. Okay, but तुम्हारा building तो काफी बड़ा है, it's big, it's wide, it's deep. So how do you take that line out? So again, remember we talked about, I don't know in which year, probably with your class or some other class, I don't remember. But when you design a service floor and when you have to take the pipes which is coming vertically, now you have to turn them and take it horizontally. and you have to take them out somewhere else. Barabar? That is the idea of service floor. Now, how do you do that? Because again, what did I say? The drainage is self velocity. If you don't have self velocity, you land up in a problem. Okay, manually you will have to scour that entire thing. How do you do that? So you see the first diagram. You see that again, concretized block or the brick block, whatever it is, because it is plastered, it looks like concrete, but it's not. Okay, it's a brick block. Basically, the brick blocks banate hain and they measure the invert levels. So they don't allow the pipe which is coming vertically to come all the way down to the floor of the service floor. No, it is turned at halfway between. And they calculate the distance that agar ye duct se mujhe turn karna hai and it has to travel this much distance, what will be the gradient? 1 is to 60 pe mujhe kya lagana padega? And accordingly, they will have those platforms. So this is how it works two ways. First of all, it controls the stack. Secondly, nobody is going to stumble over them because it is lying on the floor. Okay, very clearly these platforms are made so that it is visible. Okay, and then if the pipe has to stand on its own, some say 30 centimeters above the floor, because if you see the pipe, the orange pipe, okay, and they color the pipes. One is the waste pipe, one is the soil pipe. So that is how they will differentiate. Otherwise, how will you know which is soil and which is, besides the size, of course. But in high rises, probably same sizes would be used. So when you have this kind of thing, so the second is the protection of the people who is crossing the floor and they can't see the floor. I mean, they can't see the pipe because it's dark, dingy, it's not lighted, it's a service floor. So that is the first thing. Second is, since the pipes are raised above, how will you support them? So this is working as also as a support, but also to create invert levels. So this is how that thing is done. Okay, and do you see the tank there? That is the tank which I was talking about, where they have done primary kind of collection and releasing it out. Okay, so it is done at certain levels, though it is not feasible. And if you ask me, I don't think it's a very good system. Okay, so the second system is also showing you how the pipes are laid randomly on a service floor, because it depends. You will have to take the shortest route out, right? Because you don't want to go all around. So that is how your drainage systems are done. And then when it comes where you wish to take it down, again, you will have to give the cleaning eye. You see the water pipes that is there, and then it is taken down via the normal duct that is planned. Okay. Any questions so far, guys? With this, we complete the drainage. Drainage doesn't have much complexity, as I said, as long as you take care of the vertical and a horizontal stack, and as long as you take care of the straight vertical stack. If you take care of these two devices, more or less the drainage can handle itself. And then everything else is what Kima and we have been talking about. How do you manage your waste? How do you create electricity? How do you create composting out of the sewage? Is something we have been talking, and we have taken the classes as well. So I'm not going into that, but everything, imagine this entire thing is going into the basement, and at the basement level you will be having a large facility. So when we talk about complexity, these are the complexities. Okay,
Meena,
till now, okay? Yes.
there is a question. Can you please explain the difference between service floor and mechanical floor again?
Sure, of course. Thank you for asking that question. Very good. So service floor is, dear girls and boys, is for only if I have to divert the services ducts only. Okay, and this generally will happen. Say I'm taking Burj Khalifa, where on the top floor they have designed or rather they will say that, okay, my restaurants wants to have that feel of sea all around and at the top rooftop restaurant, and so probably they will have a kind of certain. Unfortunately, I do not have the diagram with me in this. Probably in the next PPT, I'll be showing you where I'm doing a case study, so I can show you how the entire Burj Khalifa is planned. So in that, the certain sections are hotel section, okay, where and the planning is done that way, so that one lift will come up and deal with the goods for various sections. Okay, so एक ही lift में सारा सामान आता है, or multiple saman will come multiple times, but it generally does a goods kind of lift, and so it's taken care of that. Then there is a section where offices are there. Then there is a section where there are residentials are there. Now imagine everyone will have a different setup of toilets. Now for commercial, you will have one public toilet because it's a big office. You will not have private toilets everywhere. It will be one common toilet where people will go and use the toilet. But in a restaurant, every facility will have its own toilet. But in a five-star, if it is a five-star hotel, then every room will have its own toilet. So then when you have so much of toilet thing happening there, all these ducts coming here, there, and you don't wish to encounter, I mean, don't wish to get those ducts into your nice big open spaces, आप वो ducts कहाँ लेके जाओगे? You will need some kind of turning and getting them out, na? At that point, you will, whether you like it or not, you will introduce a service floor. Okay. Now, ideally, the planning, obviously, a lot of, as I said, you saw the first, second diagram. I mean, the first diagram of those multiple stakeholders. People are there to guide you because an architect is not capable of doing these kind of calculations. We are more visual and more arty guy, right? But there are people who will be doing these calculations and they will probably suggest you that it would make sense that if you create these kind of planning stack or you create these kind of zones, then probably your mechanical floor will also fuse with your service floor. But that's not necessary. Okay. So that was about the service floor, where it only takes the main idea is to take care of the sewage pipes that is coming or any other duct that is coming out and how you wish to divert it to various other ducts that is going down. Hmm. Now you imagine the mechanical floor. Mechanical floor might or might not have sewage pipes. Okay, because mechanical floors are introduced because I cannot have one HVAC installation taking care of 160 floors of Burj Khalifa. Okay, it will be terrible. Just imagine this. There are so many diversion, digression requirements. How can you control everything from one plant? Not possible, na? Or for one boiler or from one mechanical fan, impossible hai. So what we do is, or what the engineer suggests is, since it's a huge humongous building, आप उसको zone करिए. So they will zone up. Okay, the first 50 floors, the second 50 floors, the third 50 floors. Okay, and every 50 floors you will introduce one mechanical floor where you will have a second set of HVAC, second set of boiler, second set of mechanical, fire, communication, whatever. Okay, those are my mechanical floors, which is very different from the services. Services can, there are no need for any zoning and services. So if I have rooms above and niche banquet, I will have to have a service floor in between, unless you plan your banquet in a way where you are making it into chotu chotu parts and having a different style of banquet, whatever. So I hope I'm clear. If you are not clear, please raise your hand again. I will explain it again. Are we clear? Are we clear? Whoever asked that question. Yeah.
Yes, yes. Meenal, can't
Yeah.
mechanical flows and service flows be integrated together in a high rise?
I did already say that. Of course, it can be integrated. Okay. But mechanical floors, I don't need it at every 10 floors or every 30 floors or something. Because my
Okay.
imagine an installation for a building like massive building like Burj Khalifa. Obviously, the systems will be prime. The capacity will be the prime. Okay, so obviously the zoning will also be of a level, na? But suppose you have zoned the building 50 floors. Okay, I don't know, but I'm just saying that 50 floor ka apne zoning kiya hai for HVAC. So at 50th first 50th floor of your Burj Khalifa, you will probably have one mechanical floor. Now, but I might not need services there because sab theek thak ja raha hai. I don't need it. Of course, it should be integrated. Ideally, what I just said is the reason of introducing stakeholder here was that the ideal way is that it should be integrated. But what if some of the programs in that 50 floors are again a mix of residential and commercial? Now, if that happens, within that 50 floor also, I will have to introduce a service floor because I cannot allow all those chotu chotu ducks and spoil my big one open lounge space that I'm planning. You're getting my point now?
Yeah.
Yeah, Sanjana?
Yeah. Yes, yes.
Yeah. So,
Yeah.
case one, mechanical floor, zone. services not zone, because service floor will depend on what is the function. So as I said, if suppose I am repeating this again for all of you, okay? So if your first mechanical floor is on the 50th floor, that will take care of the second 50, क्योंकि नीचे जो basement में है, that is taking care of the first 50. Then the first 50 floor will take care of the second 50 floor. Then again there will be the mechanical floor there. Now that mechanical floor will take care of the second 50 floor above. Okay, so that's how the mechanical floors will take care of. My issue and the worry is what happens that in the first 50 floor that you had, certain parts were hotel rooms were there, residential rooms were there, and they were all 5-star. And a 5-star generally has a lobby, it has a banquet, it has a theme restaurants, okay, it has its own cookery, it has everything, okay. Now if imagine those set of some 15 floors are planned for your 5-star, and one above the other you have the toilets stacked, and that toilet duct is going to enter your big nice reception lobby. Will you allow that as an architect? No. So irrespective of the mechanical floor at the 50th floor, mujhe after 15 floors of residential, and then my first 5 floors are taken as my commercial for that particular establishment, whatever that hotel is, I will have to introduce a service floor in between. Clear? Which has nothing to do with this, okay? But yeah, so Sanjana, now you will become a prime planner when you can say that how do I integrate this? So then when you allocate the spaces, you will allocate it so that your what do you call your lobbies and your housing will have a mechanical floor in between, right? So this is how it is to be done. But am I clear, or you still have doubts?
No, I got it. Thank you.
Uh, Everyone else got it? And I like when people ask questions, because there are many who will probably be confused, but because somebody asks, everybody gets clear. So yeah, I invite questions, okay? And this is little complex because we are talking about really complex situation where yes, you have issues with engineering and issues of safety. Okay, so going ahead. So with this, we finish with drainage, and I think this is the last I'm taking. After this, we quit. So fire safety and fire, I have a lot to speak on. So we all know that even if it's a small institution, okay, when you were designing in third year, and I remember Sanjana, your project as a police thing, we were discussing whether should I put sprinkler here or should I not, right? Now there are no questions when you talk about high rise like this. You will have to. Now again, then the debate was, remember the kind of discussions we all had with Kimaya and all the class and the other faculty member about where should the sprinklers come? Whether it should come in a library, should it come in a computer server room? Of course, you guys had different kind of programs, but I'm just saying, okay? So even in a police station or even in the other kind of functions that you guys had designed at that point of time, they will have a communication room. Na? Police ka to pura setup रहता है where you get these constant calls, 911 calling, अपने यहाँ पे क्या है मुझे पता नहीं, 101 calling. So you get these calls. So there will be setup of instruments, and today's day and time, people have computers. So yeah, you will have these kind of intense electrical data gathering, data storing kind of devices. And when you're talking about crime and you're talking about these kind of establishments, importance is how do you keep that data for at least 5 to 7 years before you destroy that, or you let it go. But we all know that crime scenes 20 saal purana bhi, it can wake up and it can be solved if you have data. So then if such things happen, some human error happens and your entire thing gets busted, it's a huge loss to humanity. So when you talk about safety, it's also a safety for the data that you have taken pains to collect over a period of time, invested crores of money to create that kind of setup, instruments, area, space, planning, everything, okay? And then one fine day, boom, it just goes because there is a fire or there is a mistake. There was, and things went wrong and the water started pouring and the computers busted. So we don't want that, right? So fire has these two-way, it's a two-way edge. Okay, karo to bhi problem, na karo to bhi problem. So how do you then tackle that? Oh, sorry. Guys, give me a minute. Yeah. Okay. So now when we are talking about fire, obviously it will first depends on the codes and the rules of that particular area. So Mumbai will have a different fire codes. Abu Dhabi will have different fire codes. Okay, Australia will have different fire codes. Australia, nahi, sorry. Sydney will have a different thing. So every city, I'm not talking about continents. I'm talking about cities. Okay, will have their own set of rules and regulation because every city is a separate entity. Okay, and it will go by its own context. So when we are talking about intense city like Mumbai or a complex city like Mumbai, okay, where you have diverse scenario, obviously the setup here is more stricter and more stringent than something in Bangalore. Okay, where Bangalore high rise is considered 12 floors or maybe 18 floors, I don't know, 18 meters. So that's Hyderabad. So it will be definitely different in different cities. Okay, so the all the setup has to be as per. So when we are talking about fire, as an architect, the first thing that you should do is take a NBC. If you are designing in Mumbai or if you are going outside, then take that national building code of that particular country and sit and read and jot down that these are the stuff you need to provide. Because if you don't provide, there is no point in design, because you do this lovely, beautiful, spend hours, times, months, years on the design, but you have not fitted the bylaws there, you don't get NOC. Simple. Hmm? So the generic planning is as usual. I mean, I'm not saying that there will be something majorly different. The things will what we learned in the other class is the same. There will be a static tank. There will be a firefighting tank at the terrace floor. Pump rooms will be there. Detecting systems like detectors and sensors will be there. Fire evacuation systems will be there. Okay, but yahan pe the emphasis is on this system. Okay, because my most important worry is how do I rescue an invalid from 160 floor? If a person is invalid and he happens to go and enjoy because the building is affirming to the international laws of accessibility and it has made accessible to the person in a wheelchair to access 160th floor, and there is a fire, then my worry is how do I get that person out? Okay, so my whole emphasis is on the planning of evacuation systems. A lot new systems are coming up which have not been tried. In fact, one of the system that they have tried is kind of a sliding belt, not a chute that I'm talking. Chute is very uncomfortable because it is like you have to hold yourself, you have to hold like cross armed over your chest, okay, and then enter a chute. It's like entering an MRI machine, and I can imagine that's very scary because there's hardly any air there. Your nose is touching the canvas chute on the top. It's that scary. So it's not a very comfortable system, and people who already are scared of or are having claustrophobia effect will never enter a chute. So yeah, it has its limitation. Okay. So there are these slides that have been planned, and it has been it's designed by this Chinese guy. I forgot, obviously I don't remember his name, but and it's implicated in one of the buildings in China, where what they do is they have a slide right bang next to the staircase. So people will just slide down. Like anybody visited गोराई पार्क को क्या है वाटर पार्क है ना उसमें that slimy sultan करके था. I don't remember. When I went there, it was the name of that ride. So you wear the gunny bags, and from a very very high level, some sixth floor, you just zoom down. Fantastic ride. I enjoyed it. But imagine तुम्हारे पीछे 100 लोग हैं और फायर निकल रहा है. I'm sure enjoyment will nowhere be in the picture. Okay, so yes, so how then that is to be planned. So the ventilation part comes into the picture, then the light part comes into the picture. So all this thing you'll have to keep in mind. So firefighting systems such as wet risers, hydrants, sprinklers, fire extinguishers, CO2 powder systems are all in place as usual. Okay, what is different then? It is the evacuation system that is different. Is the evacuation system. So then obviously the material specification, तुम्हारा 1.5 hour, 2 hour नहीं चलेगा. Probably you'll have to go for at least 3 hour kind of fire rating, so that the building will be able to sustain and I can evacuate huge number of people outside the this thing. And you know, when all these things started happening, the entire change in this fire safety, the core safety, the vertical safety, everything started happening after 2001 when the twin towers were attacked. So when when the tower were attacked, it seems that there was a problem within the building because there was very tight evacuation system. People were trapped inside because the evacuation systems were not planned for this kind of tragedy. Okay, now nobody will ever imagine na, ki a plane will come and shoot you right in the middle and breaking you into two. I mean, you in the sense the building into two. But well, that happened, and so the evacuation system that was planned was like a nominal system, and that was the biggest crux of the problem. People were trapped and many died, as you know, because of inefficient and insufficient fire evacuation systems. So a fire material specification is of the prime importance. So all these buildings, when they are done and when the working drawing happens, well, your BOQ will have all these kind of specifications. Evacuation slide. This is what I was talking about, which is now an upcoming thing in the evacuation of the high-rise building, and that is next to your fire staircase. FS is fire staircase. Okay, so it's basically a slide. You have it in a round fashion so that it takes minimum space. You are asked to kind of shut your eyes and then just let go. So you just zoom down without that claustrophobic effect of being trapped in a small canvas tube, and you land up there at the end of the staircase. Okay, and the ending is planned for a soft kind of a receiving. Okay, so the way so that you don't hurt your bum. Okay, so that's how the entire thing is planned. Appropriate fire rated lift. Now this is the difference in a normal evacuation and the high rise evacuation, because in the normal we say the first thing that goes off is electricity, but these lifts are made in a way that it is fireproof, in the sense it will be completely having positive ventilation. Not a speck of smoke can enter that lift. Okay, so the entire shaft is mechanically ventilated positively, so that the air, when you open the door, will just gush out. So it's like the air is meeting you out, so it will not allow the smoke to come in. So people can easily enter the lift in and can escape. Okay, so that is important difference between a normal building and a high rise building. So how do you then plan a building? Plan the lift is of prime importance, and we will do vertical transportation in the next lecture. Okay, the other thing that they are using, and I think you guys will be using it if we get chance and if pandemic allows us, is thermal imaging cameras. Okay, so before the firefighters go inside, okay, your IBM, the one, the nerve center that we talked about, will probably have this kind of imaging software which will tell you where are the main fire happening or which are the danger zones, because a thermal imaging gives you the idea of heat zone, and it kind of shows you red, orange, whatever, depending on the temperature of it. So that kind of leads you that these are the safer ways of travel and these are the dangerous ways of travel, and you avoid that area. So these are the new things that is being imagined in this kind of high rise. And then of course you will have your positive pressure ventilation, which we all know and we have done it. So all your fire escapes will be like sealed, the kind of the not even a little bit of smoke should be able to enter it. And that means your mechanical, now people again understand. Okay, can you have just one mighty, I will use a word called mighty fan sitting alone in the staircase, I mean sitting alone at the terrace level, और वो अपना पूरा lungs अंदर फेंक रहा है तुम्हारे staircase में, and that will work all the way down to the ground floor from 160? Impossible, guys. इतना तो किसी में ताकत नहीं है. Okay, so then obviously mechanical floors come into picture, where you will have a separate mechanical fan, centrifugal fan, sitting there, drawing air from the outside and pushing it into the your fire escape, right? That's why I need mechanical, because I will need these kind of instruments at every zone level. Okay, that's the reason of having mechanical. So positive pressure ventilation, utmost necessary, no two ways. You don't have it, you don't build the building. Simple. A must for a high rise staircase. And forget must. I mean, I'm saying in today's day and time, people are insisting that if the buildings are going about 20, 25 floors, you should have a pressure. And not, we are not doing it, is a different thing. Okay, that is different. Okay, mandatory hai, but karte nahi hai. A BMS system program to take care of the emergencies, and we know what is BMS system. Okay, it's a fine-tuned nerve system which takes care of all your sensors, all the movements, all the thermal zones, and everything. I'll not go into that. And these are some of the pics which will. अरे रे बीच में कहाँ से आ गया? Yes. So this is, I wanted to show you this because I wanted to show how you separate or how you don't have a continuous duct within a building, because that is a sure short way of allowing the fire to travel all the way up. Okay, this is how you stop. So yes, you will see the pipes are running down through and through. Okay, but there is a cutout in a slab in a manner where only the pipes are going in with a little leeway. Thoda sa aage piche chhod ke the cutout is done in a way so you don't keep a complete cutout. हाँ ये तो toilet duct है ना, ऊपर से 160 floor से ground floor तक खुला ही खुला. Doesn't work that way. Or for that matter, you have chill water pipes going from the basement to the first 50 floor, because then you have a mechanical floor for the other 50 floor. So that 50 floor का जो cutout होगा will not be one nice big चलो cutout है ऊपर से देखा तो नीचे atrium जैसा effect, and no way guys, I will have to have it like this. So this is how you will stop fire from going up. Smoke to control कर सकते हैं. Okay, of course this is also big enough gap for the smoke to come up, but imagine not having the floor at all. That would be like billowing of smoke. At least यहाँ पे some smoke swirls will come up. So this is compartmentalization in a building that one has to do. Oh, sorry, I didn't show you the picture. Yeah. So this is how the compartmentalization will happen. So you see the ducts, okay? You see the gap in the floor, minimal. Then you have your, so see now, please pay attention here. Generally, ये mistake हर कोई करता है. So this is at one typical floor. The door is opening in the run, in the direction of the run. So I am opening the door and going inside. Now look at the size of the door. It's not your normal 0.9. Okay. Now look at the size of the landing. Not the mid landing is where the window is. No, I'm not interested in mid landing. I am interested in the landing. So in spite of my door being open, which is a large door, look at the amount of space that is left there. So the people from the above can keep on going down without getting badgered by the opening of the door. That is what I meant when I say that you should have a double space lobby there. Okay, bigger the better in a larger higher buildings. Okay, because the crowd is going to be humongous, so you will have to take care of that. So proportionately you will have to design. Okay, the next slide is about the position of the vent that I keep talking about. How do you positively pressurize your staircase block? So this is a thing that is happening. Okay, and the next slide will show you, next picture will show you this. You see that machine? Okay, this is at the terrace level, and a very schematic diagram is shown below, where the blue square is your fan, the red dot, I mean the obviously the staircase thing आप देख रहे हो, and it is taking the air and blowing out. So wherever there are openings, so it will come out of the top floor, second floor, third floor, fourth floor. The air is moving out of the staircase and not allowing the smoke to come in. So it is a highly pressurized kind of a thing. So this is how the arrangement is to be done. So now when I imagine this in a plan, guys, so imagine you have this as a first picture is your staircase. Near your staircase, obviously now, if I don't want to lose the pressure, obviously right opposite to where the door is opening. So the door is opening on my left. Okay, so on the right hand side I will have a duct there. Ideally I will have a duct there which is going till the first 50 floor of the Burj Khalifa. Okay, and from the first floor of the mechanical floor, my mechanical fan, my centrifugal fan is pumping its air all the way into that, and every floor is getting this thing done. Okay, now suppose, and they will also calculate, क्या एक फैन से काम चलेगा, नहीं है तो चार पांच लगाओ, because imagine that kind of air moving in. But who does all that calculation? Do you think we are capable? No way, guys. So of course you will need a person who will guide you into that, but that means you will need to have that space. So who gives the space to them? You give the space to them. And then you also have to remember that when we talked about AC and we talked about the mechanical ventilation, we did talk about that these fans, okay, these machines, they vibrate, they create noise. So imagine your mechanical floor having three such fans or four such fans, and you have the boiler there, and you have the HVAC system there. That floor will have to be like major thick. Okay, and it will have to have these isolator vibration stands or the platforms on which you will keep these machines. So all these things will have to be planned, and you will not be in a position to plan unless you have that stakeholder ka thing that I showed you, right? So you will have to consult with so many people for every diagram that you will make. Every drawing will have 10 people overlooking your shoulder and telling you, nahi, ye aisa karo, ye aisa karo. And then you will have to appease both of them because you are the coordinator. So that is the complexity that I'm trying to talk about here. So this is how my pressurization of the lift, sorry, my staircase block happens. Any questions, guys? Yeah, this is clear. So this is how you will keep the smoke out. Okay, fan unit is connected in the cutout seen in the other picture. Okay, so this is just the hmm. And this is the lift room that is shown here. So the lift room, you see the size of the lift room. Now, why do you give such a big size for the lift room? If you actually go and see the lift के machine में कुछ भी नहीं रहता है, एक छोटा सा machine रहता है, which is working the job of taking that counterpoint up and down, and the lift moves. Okay, but guys, imagine it's taking four people and the cage ka load, and in case of a big lifts, probably 17 people, 20 people, who knows? Okay, it is a machine, it is creating heat, and if I fail to ventilate this machine room, well, you can be assured that your lifts are going to get conked out in some period of time, बिकॉज मशीन नहीं काम करेगा तो तुम्हारा काउंटर वेट काम नहीं करेगा, काउंटर वेट काम नहीं करेगा, तुम्हारा लिफ्ट नहीं काम करेगा. सो इट्स अ कनेक्शन. सो you need to vent, and that's the reason why machine rooms are kept on the top. Today we have the machine room less lifts available. So then again, but you need to take care of the machines. तो रहेगा ना, machine room नहीं चाहिए मुझे, but whatever is there I need to see that what are the specifications given by the manufacturer, and I need to plan for that space, because in such a scenario, guys, it is completely your responsibility to save lives of thousands and thousands of people who are going to visit Burj Khalifa, right? So these are your responsibilities. Wow. So yeah, and these are the nominal things. So that is a refuge floor, and that is this is the fire shaft. तुम लोगों को पता ही नहीं fire shaft कैसे दिखता है. Now you see the size of it. It's a minuscule cupboard which is locked, but locked with a glass thing there. So I know what is happening. I see that red dabba there. Okay, and so then that's how I will know that this is how I can access the thing, and it can be opened normally. I can access that, and this is how it works. So when there is a fire, all you need to do is remove that hose. That round thing is the hose. You just, and that red thing is the hooter. Okay, so you, there will be a hooter inside the box. We don't keep it outside, nahi to masti hota hai. In, especially in a high rise building, some idiot decides to create a havoc and जाके उसने hooter बजाया तो problem है. So what they do is, they generally, you have to break the glass. You have to break the glass, you have to press the hooter button, and then the things will happen. So all this thing is done. So in case of fire, you all need to do is remove that, remove in the sense unfold that canvas wire and take it to the place of wherever, and of course that is attached to the hydrant. You are not able to see the hydrant because it is in the side of the duct. So but you see the wire being attached to that. That is the attachment to the
Neha,
wet
I
riser.
have a question.
Bolo.
In the image that you're showing right now, the whole setup is kept inside this cupboard looking thing, but like in my building, it's kept close to the lift, but it's in the open because people consider that if there's a fire, like if you see the door, it has a lock and everything. So there's a fire and you can't find the key and all, then what do you do? So isn't it
It's
better to
not.
keep it outside?
No. It's not locked. There is no point in locking. Imagine Burj Khalifa में fire है, and all 160 fire shafts are locked. Pointless. It is a clean way of doing it. It's just that I have a door. You just unlock it. Unlock it in the sense जैसे आप दरवाजा खोलते हो टॉयलेट का वैसा ये खुलता है. But you should know it. So that's why that signage is there on the top. Also, there is that glass panel there which shows you that there is a hose reel inside. And signages are always there, darling. So you need to, if you are housing it because you want a very clean interior, you are talking about 5-star services. I cannot, I mean, aesthetically, I would want my building to give me that feel of I'm walking in a 5-star lobby, but yet I'm protected. So then I will have to give such kind of interiors. Huh? But when I'm giving that interior, I will invent a nice kind of, so there are people who do charge you for designing signages in a very creative manner. So then you get your signages done, uske upar lagao. You have to anyway, even in a 5-star lobby, you will be seen that there are signages there, exit, fire exit written there. You have to write it, otherwise you won't get your NOCs. Because how will I know where to run if there is a fire unless I don't see the signage? What if there is no electricity or EPBX room में ही fire लगा है? How will they announce that please move towards your left, right, wherever I have to move? So in such a scenario, guys, I have to have all these kind of visual as well as audible kind of systems, and that's where the complexity arises. Okay, so when I have this kind of a cupboard situation, and what you said is absolutely right. In most of the buildings, all these are exposed, which is okay because abhi normal building mein you don't really, every inch is counted, especially in Mumbai, and a builder is trying to cut cost everywhere. He's not going to provide this kind of stuff. But you talk about Burj Khalifa in a high-rise building where it is given off to these high kind of establishments. तो फिर obviously aesthetics भी चीज है ना. तो फिर when you do that, it's not never locked. But that hooter is under the control, because otherwise, as I said, log masti karte hain. And I can't afford to have chaos in such a situation, because as it is, there are so many people there, and kind of stampede that can occur, it can be dangerous. So with or without fire, people will start dying in such a case. So I need to protect that. So hooter is also actually a placement be wrong hai. That thing should be down and hooter should be up. It should be little difficult for you to break that. Shouldn't be so easily available. So generally that hose reel is kept down and the hooter is kept up, so that you actually need something very heavy. And generally wahan pe, if you see in a very good systems and services, you will see a small X also there nearby tied to it. Okay? वो लेके आपको break करना पड़ता है, and then you press the hooter button that this is a problem in my floor. Okay, and you raise the alarm, and you escape. You don't do anything with the fire. Okay, then people will take care of how to take the reel and do that. Are we clear? Did I answer your question? Who was that?
Yeah, thank
Yeah,
you.
yeah. So yeah, it happens. It's okay. It depends on what level of services you are giving and what kind of building you are designing for. Imagine our building KRVI में कुछ भी नहीं है. I mean, everything is exposed. Okay. So, but imagine the same kind of situation in a Taj hotel. Will everything, all conduits will be like that? Unimaginable, right? So yeah, even though we know that actually what we have is good, it's completely aerated. Kal subah kuch heat bhi create ho gaya, to because it is open, yeah, this is the actually safety wise it is good. But can you imagine having this in any kind of a better establishment? No way. Yeah. So coming to the, I think, not gosh. Anyway, so I think we will stop after fire. Few more slides and we are done. So in the upper building zone, so what we do is, as I said, mechanical floors, they will be, so the fire is also zoned. You can't have one OHT and one UGT and expect that every floor will get water. वो पानी का pressure से buckle हो जाएगा. The pipes will start buckling because of the pressure of the water. So I need to have it again zonalized. Okay, so this is how they do it. So at every mechanical floor, they will be having these kind of static water tanks placed, and all the related methods. You see the number of static tanks there. You see the guy who is there. So water tank and the static water tank. So guys, the establishments we are talking about is like huge. So mechanical floor can be as big as your normal floor, and still it will be less because the kind of services that goes into it is tremendous. Okay, and very focused and very highly, I would say, specialized. So this is how the things are done. Any questions on this? So you have upper building zone, and you have medium pressure, and you have high pressure. So you design the pressure as per the need of the building. So if you say that there are invalids here, hospital zone hai, then the idea is that minimum time mein the fire should be put out. So I obviously give high pressure zone there, and pressure zone is developed by giving higher pressure pumps there. So that is how I design a zone. Okay, so obviously it will have to be zoned. Now again, the zoning, who will control? Your IBM will control. So integrated building management system is there as a nerve center to control that nerve. So yes, that's the reason why IBM is so important when you have these kind of complexes, right? So coming to the next, well, this is a normal picture, but this is a requirement, especially when you have a dry riser. Okay, okay, I have, okay, this I think I will take next time because it's little complicated. In a high-rise building, na guys, irrespective whether it is in Abu Dhabi or is it in Canada, where one the temperatures are -10 and the other it's 38 degrees or 40 degrees, okay, or maybe even more, where water will never have a chance to freeze, okay, but yet I will have a dry riser, okay. But I'm going to take this next time, okay. I will not take it now. For right now, just understand that you will have a dry riser, you will have a wet riser, you will have a sprinkler riser, all three in a line in a high rise building. And everyone will function. And what is the difference? Well, there are differences in all three. Okay, now sprinklers, when we come to the sprinklers, the debate of whether should I have a sprinkler in a hospital area or in a M&E area or in a, say, library. Okay, my Burj Khalifa building has a beautiful archiving library there, which is housing the entire history of Middle East, suppose. Okay, and can I even dream of having a sprinkler there? What if there is a mistake? Ages and ages of collection, my documentation is gone for a toss. So cannot dream that, right? But is there a safer system? There are, and that is why you have a dry riser system. And what is it? Will it's little lengthy, and I think you guys are tired, and I am tired. Okay, so I'll quickly finish the fire, and a little part of the dry riser part I will conduct it next time before we jump into the two main system that I still need to cover with you is vertical transportation and waste management. So this is how the entire thing is done, where the zoning is done from the fire tank, which is there at the below, where you have the booster pumps, where you have the standbys, where you have the nominal pumps, okay, and these are the fire hydrants that needs to be there around your building at not at the 30 meters, but at very close levels where you need to come together and see that maximum amount of water is disposed at that level, or I can connect a hose there and take it up. So these are the normal things, nothing great, but these are the requirements that needs to be there. This is at the terrace level where you have the booster pump at the terrace level. We always say now when you have a static tank at the terrace level, you will need a booster pump there. And this is how it functions, okay? And these are the pressure meters on the left hand side picture. You will see that these are the pressure dials which will tell you the pressure which exists in the pipe. And the moment this pressure drops, that means there is a leakage there or somewhere the sprinkler has started. Now, if the sprinkler has started and if it is not connected to a detection system, that means there is a problem in the system. Okay, so all this thing is then taken care of by IBMS. So that is the care of, and this is the pump rooms, massive. Imagine this is for a small building that I have taken. Okay, this is G+25 building that I have got the uh, case study from. We are talking about Burj Khalifa. So these kind of pump rooms will exist on every mechanical floor. Mm. It's huge. Yeah. So are we done? Yeah. So this is the last slide for today. Well, there are more, but we'll not take it today. I had to cut down these slides because it was not loading up. So actually, there are some 60, 65 slides. I don't remember, but yeah. So what we'll do is we'll next time continue with high rise, and then I'll call a person. So probably next Monday, I'll call a person who is an expert in airport designing and planning. So we can have a lecture on that. And then probably one more lecture on my side regarding hospital planning, and then we are done with you guys. Okay. So any questions before we quit for today?